Work it, make it, do it, makes us.
Okay, you guys ready to go? You guys had a nice lunch, everyone's nice and tired, ready to fall asleep at this point. And if you saw my presentation earlier, the quickie I did, you kind of saw the awesome demo at the very end, but we're going to kind of walk through it more slowly and also cover more topics in this particular session since we have a few more minutes than we did before. My focus in this session is specifically how to do cloud-native development, microservices development in the context of Kubernetes. You know, we've certainly seen a lot of different things from a lot of different players in the market, but where does that apply and how do you bring that into the Kubernetes world? So I work for Red Hat. My name is Burr Sutter. I'm specifically a Java champion, and I do a lot of presentations around various topics and technologies. I've actually been part of the JBoss team from 2006 into now, so 11 years now, because Red Hat acquired JBoss so 10 years ago, 11 years ago. And I used to mostly be internally focused, mostly as a product manager, working with different engineering teams, defining requirements, working on usability, things of that nature. Now I pretty much go out and talk to the world about different technologies that we have. And in this session, what we're going to focus on is Kubernetes. Red Hat is the second largest contributor to Kubernetes in the upstream. We specifically have another open source project called OpenShift around Kubernetes that you'll see some aspects of that also. And then we have another open source project called Fabric 8. And you're going to see some aspects of that. And so there's going to be a lot of interesting stuff from that perspective to just kind of get your head around what's going on in this universe. And our entire focus is on basically making it easier to build cloud-native applications on top of this architecture. And you're going to see some interesting stuff, I hope. And so let me ask a couple questions. How many people have been hands-on with Docker at this point? Okay, the majority of you, it looks like that. That's common for conference attendees, not as common in the regular world, right? But for those of you who are elite enough and blessed enough to show up for conferences, meaning the boss lets you go or even paid for it, or you paid for it yourself, and thank God for you for paying for it for yourself. But that makes you guys kind of unique. How many people have been hands-on Kubernetes at this point? Okay, vastly fewer people. And that's good, because we're going to kind of walk through Kubernetes at a high level, show you a bunch of different commands, but more importantly, show you what kind of workloads you can run on Kubernetes and do things like canary deployments and things of that nature. So it'll be pretty fun. So let's go ahead and dive right in. I represent a team called developers.red.com, so if you could, just feel free to go to developers.red.com, try some of our free ebooks, like on Vert.x, microservices. And one book in particular that's particularly important is by Edson Yanaga, who works on my team. And it's dealing with the monolithic database. So by default, most people who get stuck in a microservices architecture, like how to decompose and blow up the monolith, break up the monolith, is what to do with the monolithic database. And that particular book specifically walks through several strategies for how to deal with that. So we find that's the number one question on people's minds is how do I decompose my monolith when I have a monolithic database, which most everyone does. First of all, you got to kill the DBA. Just keep that in mind. I'm just kidding. I'm not advocating any kind of form of violence. But do go check out that website, books and downloads from there. Now, I love this particular quote. We cannot solve our problems with the same thinking we used when we created them. So we're living in a brand new world when it comes to cloud-native architecture. So if you think in terms of cloud-first architecture, you do write your applications just a little bit differently. Not dramatically differently, but a little bit differently, and we'll kind of show you some aspects of that. All right, I really love this concept of the developer journey. I talk about this a lot. I talk about the fact that typically you need to be thinking about DevOps. And the reason I talk about this is because everyone thinks they can jump immediately over to the far right. And I see this time and time again as I go out and talk to different people who are actually started their microservices journey and things of that nature. They're very much focused on, how do we build our microservices right now? And they don't actually have the DevOps principles in place. They don't have the automation in place. So some of these are super critical, and we'll talk about them briefly. But one here in particular is, do you have some form of self-service on-demand elastic infrastructure? If it takes you 3 weeks to get a virtual machine inside your organization, you have a fundamental problem, okay? And now, I say 3 weeks. Some people are going, 3 weeks? Wow. My organization is 6 weeks. And so, and some people are thinking, what? I do that in 3 hours. It should take you like 3 seconds, and it should be API-driven and something that you can just get access to all the time based on quotas assigned to your account within the organization. This is no longer hard. The technology's been out there for years. It's all in open source if that's what you want. It's, things like OpenStack and CloudForms and things like that are available to you, but even Kubernetes can help you with some of these problems. You need to think in terms of automation. If you're actually building servers from scratch, like with SSH and then systemd or init scripts and bash scripts and things like that, that's a problem. You should be baking out servers with a full script, whether it be Puppet, Chef, or Ansible or something like that, or in the case of Kubernetes templates or Kubernetes manifest, you could do it that way also. So we're really going to focus in this session, though, more around advanced deployment techniques, than the rest of this, but there's different presentations we have that cover all this ground. Okay, so let's kind of jump in here. From an IT standpoint, things have changed. We used to be waterfall, we kind of moved to agile, now we're talking about DevOps. That's super critical to be thinking in terms of working together from a dev and ops standpoint. We have used to build monolithic architecture, now we're focused on in-tier, or we're focused on in-tier architecture, and now we want to talk about microservices. And of course, we used to be in the physical server mode, virtual server mode. Some of us are still in physical servers, not on VMs, but now containers. So in this new world, in the Kubernetes world, many of you raised your hands for Docker. You've already experienced the container magic, right? If you did your first Docker build and Docker run, you were like, wow, that's amazing. Now we're taking that to the next level. How do you do Docker run, Docker run, Docker run? In many cases, and that's what Kubernetes offers us. And then, of course, the data center has changed. And actually, I remember back in the day when we had mini towers sitting on people's desks, and that was the data center. Anybody have that, before, right? That was where we went production deployments was on someone's desk. And then, of course, we moved all that to nice 1U rack-mounted servers that went into the back, into some nice air-conditioned room. And now we're talking about getting rid of all that and putting it into the cloud. So these things are always changing. Also, the core principles around how we think of software development should be changing right now. So if you think in terms of build and continuous integration, we should be doing that all the time. And most people don't actually pass Jez Humble's test in this category. If you've ever seen Jez Humble give a presentation, and he's the fellow who wrote the book about continuous delivery, he has 2 tests when it comes to continuous integration, right? One is the software that goes in the trunk is immediately deployable to production. If you check in the trunk, that code we know is good enough to go to production immediately. And that some people are like, okay, my testing is solid. We got great integration automated tests. We know our stuff is ready to go. The next test is even more interesting. And everyone on the team checks in the trunk daily. Because one way people get a nice clean trunk is no one's allowed to check into it. Right? And then you guys probably have lived that life cycle also. So if you're not actually checking in the trunk daily, and you're not doing automated builds of that and automated tests of that, you're actually not doing continuous, right? If you're living on a feature branch for 3 weeks, you're integrating every 3 weeks. So that concept is super important, and a lot of people have to do a lot more work when it comes to discipline in terms of getting their continuous integration strategy working. But continuous integration, continuous testing, then informs then you create a continuous delivery pipeline. That's like your Jenkins file, and using something like Jenkins 2.0 to actually do that sort of thing. And then maybe you go into deployment. And what we want to show you in some of the topics here is the concept of how you go rapidly into production, and that's what we believe Docker containers and Kubernetes allow you to do. So let's kind of show you that. Now, this is an image that I had my designer build because this is how I perceive typical software development today. You have this big amorphous blob and a large team of people trying to push it up a hill, right? Push it up the hill and get it over the hump. And you also have people pushing back and people dragging it down. And so the concept of deploying rapidly is actually super hard for a lot of organizations, right? Because you hear about the unicorns that are deploying, let's say, multiple times a week or multiple times a day. In this context, it actually can be a lot of work. And the worst part about this is, let's say it does take you 9 months to get over that hump. You have more humps to come, okay? That's kind of the idea. In the future, we want software development to be more like this, where everybody's in alignment. It's a small team in alignment with a nice, cohesive, well-structured piece of code that's easy to push up that hill. Because going to production is never going to be simple, right? It kind of matters. We're going to show you some things that make it look super simple, but it does matter for most organizations, especially based on regulatory requirements and other requirements within the organization. Production's hard, but it doesn't have to be as hard as what you saw in that previous image. Let's keep going here. Okay? Now, if you're a Java programmer, which is the world I come from, then Java programming, in a case of a microservice architecture or some form of lightweight framework, is super easy at this point. Dropwizard certainly kind of popularized this concept of the fat jar. Vert.x adopted that same principle many years ago. And then we see things like Spring Boot, using that technology now, or using that concept now. And, of course, Wildfly Swarm, which is part of the micro-profile effort, which is another session like next door right now. But how many people here are using Dropwizard? Okay, a fair number of Dropwizard people. Excellent. How many people are using Wildfly Swarm? Anybody? One gentleman there? You can raise your hand proudly. It's okay. And then how many Vert.x users here? Okay, the one sitting in front of you. You guys know each other? No, I'm just kidding. And how many people are using Spring Boot? All right, so that's a fair percentage of you. So these are different, and of course you can do different things different ways, but these are the ones that are super easy to get started with as an example. But building a simple fat jar and loading it up or running up a Java-jar is pretty easy at this point. There's no hardship here. What's hard is now figuring out how to actually wrap that thing in for some form of rapid deployment. So in the case of microservice and cloud-native apps in general, these are the key principles that we focus on. So you have to kind of focus on the concept of discovery, managing your public API. How are you going to invoke that service, right? So I got to be able to find it. I got to know what its API is. Am I going to invoke it with HTTP or invoke it with some form of messaging architecture? Does it have elasticity? Can it scale? If everyone starts pounding on it pretty hard, is it easy to scale? Does it have resilience? If it actually dies, does it fail over nicely? Or more importantly, if it gets slow, what happens in that situation? How do you deal with a slow actual service that is actually part of our chain of services being invoked? Because any single point of failure in there could actually slow down the entire application. Pipeline, of course, how do you do your deployment pipeline? Is it automated or is it manual? That's an important part of it. Authentication, you want to make sure that the users that are invoking the top-end, front-end, the edge service, maybe the API gateway layer, are authenticated all the way through the chain of services that are being invoked. How are you managing that? How do you manage logging across all of it? One thing cool about Kubernetes and things like Docker, if you actually just log the system out, it knows how to grab all that and then pull it right into a central repository. And we use something called EFK, so Elasticsearch, FluentD, and Kibana. So those are the three we like. So we don't use ELK. We eliminated Logstash and use FluentD. But you can use whatever you like, right? It's just a way of gathering logs. Monitoring, you want to be able to monitor across the batch. And so a lot of people use Prometheus in this kind of world. That's a common thing to see in the Kubernetes world. But we also have another technology out there called Hawkular. And Hawkular helps you do monitoring of these components within the fabric. And then, of course, tracing. And tracing allows you to actually figure out how did a transaction flow through this system of services. Did it go from A to B to C? Skip D, go to E, skip F, go to G? And that might be very important for your understanding of how something actually happened. So all these we consider to be key principles and core principles that you want to wrap with your microservice. And one thing that you'll want to do is ensure that these things are set up in such a way that hopefully they don't interfere too much with your business logic. And that's actually where the problem is as of this moment. Right now, they do invade and pervade your business logic. And there's some things we're working on from that category that I'll talk to you about as we go. Okay, so most people here have done some Docker, and Docker, of course, is super awesome because it allows you to define your stack. This is why I love Docker, and when I first saw it, I thought this is awesome. With my Dockerfile, I can actually say, here are the core prerequisites to run my app, whether it be my war file, my jar file, my ear file. I know exactly what my operating system needs to be at the right patch level. I know exactly what my JVM should be at the right patch level, because oddly enough, an operating system patch or a JVM patch could break your code. I've seen it happen before, right? Literally, just a different patch level of that 1.7 point something of the JVM could blow up your code. Now, in theory, it's always backward compatible, but it's not always true, right? So the JVM could blow you up. You also have to get your app server exactly right, and you have to decide exactly how that app server will be configured with your JDBC driver, your data sources, your JMS queues. So this was the beauty of the Dockerfile, right? It allowed us to codify all this, make it programmatic, when it used to be an email that was sent back and forth across team members. We used to send an email to the QA team. Oh, here's the war file created for you, and in order to deploy it, here's an email of all the steps you need to deploy it. And some of us got really clever. We was like, okay, we don't do emails anymore. That's too manual. We have a wiki page. And the wiki page is never up to date, right? So when the QA team receives it, they can't deploy it because someone forgot a step in the wiki page. If you have the Dockerfile and an immutable image that moves from dev to QA, they know exactly what they're getting and they know exactly how to run it, right? At least all these parameters are figured out for them. Now, in the case of Docker, how do you scale that, right? So let's say you do have a Tomcat, Postgres, a Wildfly, a Spring, whatever it might be. You have all these components. How do you scale it across multiple nodes, multiple pieces of hardware? So yes, you can SSH into every machine and Docker run, Docker run, Docker run, Docker run. You can also use Docker Swarm mode, right, which helps you do that distribution also. But in our case, we use Kubernetes for this sort of same thing. So the idea behind Kubernetes, of course, it comes from the Google team. They invited Red Hat in very early on to the project. They actually told us about it early, and so we actually said we want to be a part of that as an example. So we actually are one of the greatest contributors to Kubernetes outside of Google proper. But the nice thing about it is it helps you with scalability, managing these components and workloads across all these different nodes, dealing with port conflicts. Like in my case, I'm going to run everything on 8080 on this one machine because it's being managed by Kubernetes. You got to manage multiple hosts. And then, of course, if something breaks, how do you fix it? How do you recover from it? And there's all this capability and automation within Kubernetes itself to help you keep your containers up and healthy, and we'll show you some examples of that. Okay, so that's the Kubernetes. It stands for helmsman in Greek, so the pilot of the ship, because the image of Docker is this container ship, so it's the pilot of the container ship. That's kind of the idea. So it's a container orchestrator. It supports, it's available on all these different clouds, right? Public clouds. It's also on bare metal. You can run it on your laptop. We'll talk more about that in a second. And of course, you have the ability to run it anywhere you would like. And it's actually pretty straightforward. Now, A Kubernetes cluster might look something like this. There's a master with etcd and API server, basically that's responsible for ensuring that all the worker nodes, what used to be called minions, but are worker nodes, if you will, they're the guys running the actual Docker containers. Each of these guys have something on them called a kubelet, right? The kubelet is, think of it as a daemon, if you will. Basically, it's a little agent, and it's responsible for running the jobs that have been asked that are supposed to run. It also does monitoring of the containers to see if they're healthy or not. And if the containers are unhealthy, it'll stop and restart them if necessary. And if other things have gone wrong in the system, it'll rebalance also. So that concept of having that master and these different nodes means Kubernetes can manage that entire cluster. The challenge for Kubernetes is always that it's kind of hard to learn. I'll show you some aspects of that and some ways we've actually been working to clean that up, make it easier. Now, the key core concepts within Kubernetes are specifically the concept of the pod, right? So the pod is one or more containers. So that's an important aspect of it. It was never limited to a single container. You can actually pack 2 or 3 containers in that pod very easily. And that's actually going to be important a little bit later on. Typically, most people just put a single container in a pod, okay? They have a shared IP, shared storage. Basically, they see each other on localhost, essentially. That does mean that 2 containers in a pod can't actually be on the same port because they share the same IP address. So just keep that in mind. If you do stick 2 of them in there, can't both of them be on 8080. But if you have 2 pods, right, 3 pods, they can all be on 8080 is the idea. You have the concept of replication controller or a replica set and a deployment. This basically manages the specific number of pods that you want. So you basically say, I want 4 pods running all the time in this cluster. It ensures that 4 stay running all the time. You can also ask to say, I want 5 now, and it'll ensure the scheduling of the 5 across the cluster. You can then say, nope, I want back at 3, and it'll make sure the other 2 are torn down and you're back at 3. So it manages that from that perspective. You have the concept of the service, and this is where it gets pretty interesting from us from a programming standpoint. So they've actually separated the virtual IP that people talk to from the pods that come and go that are highly ephemeral. All right, so the pods could be rescheduled, rebuilt, come up essentially on a different IP address based on what node they show up. And of course, if one fails, it gets restarted maybe someplace else. But the service is more persistent. So you interact with the service, specifically the service name, and it ensures that it routes accordingly to the right pod, and it gives you load balancing for free at that layer. We'll show you some examples of that. You also have the concept of labels, and the labels become super important because a service, for instance, can have a selector of what pod should be in its list of load balanced pods based on the label selector. And I have an example of that too. Okay? So the concept of the pod, people are probably wondering where that word comes from. It basically comes from the concept of, from a Kubernetes standpoint, it's a family of whales, because the symbol for Docker is a whale. It's a family of whales or dolphins. Some people thought it referred to the pod people. You remember the old 70s sci-fi movie, I think it was, maybe early 80s? Okay. One more thing that should be important to note is we, Red Hat, specifically extend Kubernetes. Kubernetes is the kernel, if you will, and we add some things on top. And those things on top are specifically based on this thing called OpenShift, OpenShift.org. And I just highlight them here in red so you're familiar with them. So this is where we're trying to make it easier to use from a developer standpoint. So we add a routing layer based on HA proxy right out of the box. So by default, you get load balancing across routes, and you can actually map routes to services very easily. You also have the concept of builds and image streams. So we assume that you want to do a build of an image, specifically a build of the image in Kubernetes, and treat it like a build farm. So instead of building on an individual user desktop, which could get you in some trouble, right? You actually build in the cluster itself. And that may sound kind of weird, but if you want to ensure that you got exactly the right image baked out, or more importantly, let's say a bug has been found at some high-level image layer, for instance, the operating system layer. Heartbleed has just happened. You've seen the new CVE, you want to react to it, you want to rebuild at that layer. Well, that means all 300 of your other images have to get rebuilt also. In which case, if you have a build farm to basically say rebuild them all, retest them all in a clustered way, it scales out better. So that's why we focus on that, the building in the cluster itself. It also ensures no developer can mess up, if you know what I mean, because we have the exact base image that we want. So those concepts are pretty important. The concept of the deployment, which is now Kubernetes proper, actually came from OpenShift originally. So what you'll see is we'll do innovation here at the OpenShift level and then contribute that back to the upstream on the Kubernetes side. So that's typically the way Red Hat works, right? We work within some form of downstream project, bake out an idea, work with the upstream project, say, would you like it back? And move that back. So everything you see in this world from an OpenShift standpoint is also Kubernetes in most cases, so you can just treat it like Kubernetes and just do kubectl. We'll show you an example of that. Okay? Of course, if a node gets killed, then of course we rebalance those containers to available nodes. So just keep that in mind. It's all magic there from your perspective. You don't have to worry about it. Now, let's kind of just show you, let's see if I can run this demo real quick, just to give you a quick feel for a simple Kubernetes app. Okay, let's see if I can find it. Actually, let's kind of show you some different things. Let's try this. OC status and kubectl get pods. Let's make this a little bit bigger. Okay, let's just have some fun with it. So I'm actually running a local environment here. I'm basically running a virtual machine here in VirtualBox. Where's my VirtualBox? Right there. Okay, I'm running this thing called MiniShift, and I'm actually running a fair bit of memory, 7 gigs of RAM, because I'm running a lot of stuff in this. So if you're actually running a bunch of JVMs inside the cluster, this is a single node cluster running here on this laptop. I've SSH'd into it over here, right? So let's see if I have any memory left. I don't have a lot of free memory right now, so I've actually been using a lot of stuff here. And if I come back to my external command line, let's see, Docker PS, oh, not connected. This one should be connected. There we go. You can see I'm running a ton of Docker processes, and if I do Docker images, I get a ton of Docker images. At any given moment, this thing could go blow up, right? I'm running a bunch of stuff, but I'm running a whole cloud here, if you will, and I've been doing a lot of work against it from a developer standpoint, and it's all local. So that's one thing we really like about it. But let's just take in a simple example. Let's try this, okay? Let me go to Spring Initializer here, and so let's call this artifact demo2, and let's give it the web dependency. So let's say we built our little Spring app that way, we unzip it, and there it is, okay? So let me go over here to demo2, okay? There it is, so Maven clean compile package, so it should just compile it nicely. Now this is a way to just build a simple Spring endpoint. And there we go, so let me open that up. And I tend to use Visual Code a lot lately. We've actually made contributions to it. It actually can do Java now, as an example. But let's do this. Let's call this my REST endpoint. And I'll just cheat. I'll copy and paste from one that I already have working over here, just so you guys can get a feel for that. Okay, so let's just do that. And we got to get it in the right package. Looks about right. I got to give it the right name. And let's see. All this thing is going to do is just give us a REST endpoint. Now, if I did that correctly, let's see if it still compiles. All right. Yep, I messed something up. What did I mess up? Bind annotation does not exist. What did I do wrong? It's telling me it can't find Spring. Now that's unusual. There it all is. I'm in the right directory. Yeah. Can't find some. Oh, REST controller. Let's see here. Where do I have the word controller? That guy. I can't find that guy. How'd that happen? Okay. What's that? Web dependency? But it's always so okay then. Normally I don't have to add that. Did I not click the button correctly when I did that generation? So web. Look at that. Let's see here. No. Oh, I didn't click the button. All right, let's try this again. Web. There. That was the problem. It would help if you actually click the button correctly. All right, so let's just do that. That way I don't have to worry about it. All right, so demo 3. Let's look at the code. All right, source, endpoint. There we go. And my REST, just to make it easy. Do I still have that code there? No, I do not. Let's go back and get it. All right, so if let's try it this time. This is taking too long. You guys are already getting bored, I know. All right, Maven clean compile package. This is how you know it's live. You just make stuff up. All right, there we go. Compile for me this time. I have had problems with that user interface before where I didn't click the thing correctly. Okay, now here's where it gets a little more interesting. So I just have this standard thing. You can. It's now a fat jar, right? So if I want to run it directly from here, no problem. Just java-jar, run the fat jar. But that's not that interesting. Let's do this. OC status. Okay, OC new project. My stuff. Okay. Now watch what I'll do. And I'm going to go copy and paste this little command also just because I don't memorize it, which is unfortunate. But at some point we will. All you got to do now is add the Fabricate Maven plugin. Let's see here. All right. So the Fabricate project, while that's working, is a bunch of different things. One of which is specifically the Maven plugin, but also is a bunch of Kubernetes manifests and a bunch of tools that help you kind of get things set up correctly, okay? So this is a pretty interesting project from the perspective of how do you make developer productivity happen on a Kubernetes, from a Kubernetes standpoint. And if I did this correctly, 8 deploy, okay? So you basically, at that point, have generated all the Docker and YAML files needed for Kubernetes. So if we go back here and look at it, here we go. And we look under target and classes, meta-inf, and then in my case, I'll use the OpenShift version, but there's the Kubernetes ones also. So typically in the Kubernetes world, you write this YAML code, okay? You basically, like, here's a good example. Here's a deployment. Let's make this a little bit bigger. And okay, you typically write, there's different labels and annotations that are in here, but you can see there's the replicas, we want one, the labels associated with it, the template, and you'll see things like the different ports that are going to be available. We opened up Jalokia by default. That gives you the Java console, so you can actually see inside the Java JVM. And this one, unfortunately, doesn't have the readiness probe in it. Let me see if this one does. I'll show you an example of that in a second. But right there, okay? But all this is done for you, and if I did that correctly, let's see here. Go back over here. We have a console that sits on top, but my stuff, let's see. Open up, and there it is, and there's that Spring Boot app now running inside Kubernetes. So if you take one thing away from this session, it's like if you want to try Kubernetes and you want to get started fast from a Maven or Gradle perspective, the Fabricate Maven plugin shortcuts a lot of stuff for you and makes a lot of assumptions for you. Now, if you want to go beyond that, let's say you want to specialize it, you can. You can actually add YAML fragments for very specialized Kubernetes features into a Fabricate directory, and I'll show you an example of that in a second, but that will give you the rest. So here, let's go find one of those examples. I got so much stuff on this machine. Let's actually do that. And actually what I'll do to save resources, OC delete project, my stuff. So let's get rid of that, or just remove it from the cluster. Back over here, not that one, this one, okay? So like, here's a good example where I wanted to add a readiness probe, okay? So in this case, the Fabricate Maven plugin couldn't just assume what URL do you want to be your liveness probe or readiness probe, as an example. So what these are useful for is when Kubernetes actually launches that particular container, runs it into the cluster, it then has a kubelet actually interact with it, poll it, talk to it. Are you alive or are you not alive, right? And if it's not alive, it actually restarts it. So that's the liveness check. There's also a readiness check. The readiness is slightly different, and the readiness's purpose is to ensure that it can be part of the load balancer. Is it ready to receive traffic? So you use the two of them and your business logic accordingly to decide, am I alive or dead? And if it doesn't get a response within so many seconds, it'll assume you're dead and restart you. And then you have the readiness probe to say, are you actually really ready to take real workload? So in the case of the readiness, you would actually do things like make sure your database connectivity is there, ensure your caches are warmed up, and ensure that everything else is ready to rock, and then you're ready to be part of the load balancer. Okay? So that's what those two guys are for, and that's really what, this is a good example where in Fabricate, we couldn't make the assumption, but you just add this little bit of YAML. Again, it's typical YAML like you would see in a Kubernetes world. It's just a deployment right there, and then you deploy with it. Okay? And this is a very similar application that you saw earlier with Spring Boot, but it basically has a couple things here. Are you alive? Are you ready? And those are the ones, and then there's a prepare to die. And actually, let's see, do I have that one running still? Okay, we don't want to run out of time. We got 20 minutes left, it looks like. Okay, we're in good shape. Let's go here. So this is my live one. And close some things down. All right, so that's what this guy is right here. And let's do this. Man, that's hard to see, isn't it? One other thing I'll show you here. Oh, wrong directory. Dun, dun, dun. Yeah, let's do this. Yeah, to live and ready. All right, let's do this. Cube. It's two back. Kubetail. Live and ready. If you guys, this is another great tool for you guys to look at. Kubetail. OC project. Live one. All right, let's kubectl get pods. So one thing you'll see also, we have the OC command line as well as the kubectl command line, kubectl, as some people say. You can kind of go back and forth. Basically, if it works on the kubectl side, it'll work on the OC side. OC just adds stuff on top, like things that are unique, like a build is a good example. I would actually issue a build command right now. But in this case, I want to do kubetail. It's actually a bash script you can download. And the cool thing about it is it matches all pods with the name. So in this case, I have 2 pods running. You can see and there, and actually, you know, it's going back and forth and actually looking at those, it's tailing those logs. So in this case, I don't know if you guys have heard of kubetail before, it's a great little script. But in this case, you can see my readiness and liveness probes are being called. And now if I come over here and let's kill it, as an example. Let's kill one of them. We'll call the prepare to die. All right, one of them's marked for death now. Basically, now it's going to return a negative on that liveness probe, and Kubernetes will realize it needs to be killed. You can see it says marked for death. And go back over here, and you can kind of see it going through its redeployment process right now. So it's restarting it for me. So any kind of business logic where you actually can write, you know, is my application okay or not okay? And we've done this historically, right? If we had stood up any kind of public website at all, maybe we even hired a third party that would poll our website, hit different URLs to see if the site was up. You kind of get that for free in this Kubernetes architecture. But that's part of the magic. That's how it knows things are okay or not okay. And actually, kubetail does fail once it gets disconnected from the dying pod. But you can see we had one that was an error, right? It was no longer live, and it's in the process of bringing it all back up. And let's see here. Okay. And we'll just continue. We'll just let that go. But for now, let's kind of jump back in here. So I want to kind of show you. Let's show you another example of this. So that's the live and ready. Okay. Step 2. All right. So let's try this. I'm just kind of making stuff up as I go, but I'm just changing the code that basically, you know, gets that endpoint basically on the root. It actually returns this. Let me do this now. So Maven clean fabric 8 deploy. So I can redeploy it also. And this case is going to go through the build process of the Maven build, produce the Docker image, so you'll see a Docker build, and then it'll push that into the OpenShift side of things, right, into the Kubernetes environment. We use something here called S2I. You'll see that go by there. So there's our Docker build, pushing the image, and then it gets rolled out. And then it has to go through its deployment process. Let's see if that's working. Let's see here. And there it's going through its deployment process now, and actually trying to start the new pods based on the new code that I just pushed out there. And so that's all managed for you, and you can kind of just play with it. And then again, I would recommend you try some of this stuff with a local Minishift or Minikube like I'm doing here, okay? So just keep all that in mind. Kind of recap this real quick. Let's see here. In the case of a typical Docker world, right, you'll do your standard Docker build, okay? You'll do your standard Docker run. If you create a pod around it, you'll just simply do kubectl create -f. So you see create -f a lot, and you'll see a bit of YAML, like I have here. And this is the YAML that I had earlier. Okay, for a very specific Vert.x application. So in this case, I'm building the Vert.x application, running it in Kubernetes, and that's how you get a pod started. Typically, there's always some form of Docker build, kubectl create. That's the pattern you use. But with the Maven Fabric 8 plugin, you can kind of use that to automate this step, automate this process. Make sense so far? Moving too fast? All right, let's keep going. Okay, there's some other things I want to show you there. Let's see. Cube. Let's see what I have running out here. And I'm using the OpenShift console to kind of help me see things visually. So I have live one. Okay. And actually, let's do this. Let's do a OC delete live one. So OC, again, is just a command line. Project. There we go. Yep. Okay. And you can see that one's being terminated now. All right, so let's jump back over here. and rock through a few more of these slides. So, getting into Kubernetes world can be relatively easy once you understand all those YAMLs or something like the Maven Fabricate plugin. I have a whole series of steps to walk you through if you look at that particular Git repo, and you can kind of learn it from that perspective. We talked about Jez Humble already, but the concept of deployment pipeline is super important. I don't actually have the deployment pipeline Jenkins file demo working on this laptop, but to kind of give you guys some examples of that, you can do a blue-green deployment fairly easily. You basically do the automated build of your Docker image, the immutable image that moves from development to QA to staging your production, and then when it lands in production, if blue was the last one, it lands on green, and then you just switch the load balancer back and forth. And if things have failed, it's easy to turn it back around. This is super easy from a Kubernetes standpoint. It takes almost no effort. You kind of get this for free. All you got to do is switch the route or switch the service, depending on what layer you want that at. So that's actually very nice. If you've never had a blue-green deployment option before, it's like superpowers for you, right? It's a whole new thing. But the one downside to blue-green is it's all or nothing. All the users get the new green, or all the users get the new blue. You can go back and forth, but all the users get everything. There's another option, and that's the canary deployment, where you can just get a fraction of the users to a specific version. The concept of the canary, as we talked about earlier, came from the canary in the coal mine. So the idea here is that you take literally a canary, a bird, into the coal mine, and if the bird dropped over dead, you knew that you had a problem in that coal mine. You knew that there was poisonous gases in the coal mine. So one thing, that's where this idea comes from. So the idea is it's still an immutable image build, just like we saw earlier, that you're putting into production. It's just that it's landing in a particular location where you're only going to send a fraction of traffic to it. And again, it's not very hard Kubernetes. So you're going to put the canary out there. If it lives, you're going to increase traffic over time, okay? Grow it, grow it, grow it, and if you have to, roll it back. So this allows you to deal with a certain fraction of users. And if you want to get super sophisticated, you can actually say what types of users. Now, that's not a Kubernetes-specific feature. That's something you would add on top. But, well, I only want iOS users to see this feature. I only want employees of the company to see this new version, as an example. Let those folks test it before we roll it out to everybody, let's say. But, that's more sophisticated than the demo I have. But I want to show you a couple other things in this context. The concept of the canary, actually, I've been doing that presentation now for a while. And people always say, great, now we have blue-green deployments, canary deployments. Kubernetes makes it super easy. Yes, it's super easy. But they're always stateless by default, because that is the nature of cloud-native applications. We always say, from a 12-factor standpoint, you have to be stateless, right? That was one of the rules, stateless. But one of the common questions I kept getting from people was, well, what if I'm not stateless? I've not built stateless apps my whole life. I've only built stateful apps my whole life. As a matter of fact, I build business applications, and how many business applications have you ever heard of that have no data? Right? No state. So the idea is, how do you maintain state across a canary deployment, or even a rolling update? So let's see if we can kind of show you that. And this is the demo I ran earlier in the quickie, but I will try to walk you through it a little bit more simply. So a real key to the magic here does rely on the readiness probe. But basically, you start the new pod, and when it's ready, meaning it's connected all the other memory it needs to connect to, it's actually populated its cache, then you know you're good to go. Basically, it's replicated the state from one pod that was dying to the pod that's now living. And then, of course, once you're living, you're off and going. And then you kill the other guy who doesn't have to be there any longer. So it's actually a pretty simple idea. It takes a little effort to figure it out. It took me a while to figure it out, working with the team to make this demo run. But let's see here. So all these examples, the hello boot, we kind of ran for you there. But there's also the live and ready. They kind of showed you that one also. And then there's the concept of a simple canary, and then InfiniSpan. So let me show you this. Let's see if the simple canary will run for me real quick. Let's see here. Okay, go back over here. If I have that guy still running. All right, so we have two of Aloha running here. You can kind of see what that looks like. Okay, it says Aloha 1. And if I go over here to this little window here, let's see here. I have these little scripts that help me poll things, so you can kind of see that the endpoint is up and live. All right, so it's just polling. It's hitting this particular set of pods. There's 2 pods there. One thing that's important to note, because there's 2 pods, right, you can kind of see there's 2 different host names there, because all this code is doing is returning the host name. Every piece of code that you write from a Java standpoint thinks it's on its own unique host. Right? It thinks it's on its own server. So that's what it's doing. It's returning the host name, which, of course, is the pod name. If I drill down here and look at the pod names, you can see there's the 2 pod names right there. Okay? So there's 2 in the replica set. But again, that service, the Kubernetes service, is sitting on the front, so it's load balancing for free, because by default, curl doesn't care about maintaining a session. You can do that by adding the cookies, but we're not going to do that for now. let's see. Now, if I go in here and make a change to this code, right here, yeah, this one. This is a Vert.x endpoint in this case, so it actually sets up a little bit differently. And let's go to, just make this Burr. I'm originally from Hawaii, so that's why I like Aloha there. Okay, but I'm just going to change the code. And if I did this correctly, I can go over here. Yeah, and let's see if I did this correctly. Maven, clean, fabricate, deploy. Same pattern you saw earlier. And it's going to go through the build process. There it goes. Up, 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 up. I'm in the right place. Oh, this one's not. I didn't do that specifically here. That should be important to note. I wanted to show you a different way of doing things, so I confused myself. So in the README file, I actually walked through the different steps to set up a canary purely with OC command and just all command line driven, right? Where there's no automation, if you will, just so you can see every individual step. And one of the things that I've done is I actually have that build process set up just purely as a command line. So you basically start build, project, let's see here, get projects. I'm in the wrong project. Let's see, project and simple. That's why I couldn't actually execute that command. So basically I've changed namespace, changed the context. Let's see if we can get our build to go now. So it's actually doing the build. So there's the Docker build flying by there. That went real fast. And you can kind of see we should have had a new build of this guy. And if we did things correctly, let me scale it up. So this is basically just changing the replica count if you're familiar with Kubernetes. Oh, and I actually have an old version of the image out there because the new image has not rolled out yet. Okay, so let's see here. Oh, you know what I did? It helps if you actually compile the code. Maybe clean compile. Again, this is more of a manual option. All right, so let's compile the code. So with all my mistakes I'm making, hopefully you guys are learning something from that, right? Like practice more if you're going to do a public presentation. That might be what you're learning. But but you hopefully get a chance to see some of what's behind the scenes here too. But if I forget to actually do a compile, it does not work. Hopefully I saved it this time. I got the Docker image built with the right jar file this time, and there's Aloha Burr. Okay? And again, the simple example is, if I just scroll this down, scale this up, we basically are changing the percentage of users on that new version. And at any given point, if I decide, things aren't going well, I need to roll back, I can. So you can see we're mostly Aloha Burr now based on our percentage. And you can have really fine-grained percentages here. I'm just actually manipulating these number of pods. But I can say roll back, roll that one back up, roll that all the way down, and basically take it right out of production. So that concept is super powerful. This allows you to do something like test in production now. Because in most cases, no matter how hard we work on the front end of our deployment pipeline, we know exactly how our developer workstations are set up, exactly how those images are being created. We know everything we can possibly know. Production is always a little bit different, isn't it, than everything before it, right? Even before staging. So this allows us to actually test in production and get a little bit of workload out there and see if it works or not. And with something like Kubernetes and OpenShift on top, it makes it super simple. Okay? All right, and again, all those instructions are in that document, but let me show you one that's a little bit more interesting here. And I have an elementary one, and I normally like to teach, and teaching takes several hours, but let me kind of just walk you through this briefly. So this is, I call it Hello World Infinispan. What this allows me to do is add stuff and delete stuff from the cache, right? Basically interact with the cache, and it's all in memory, 100% in memory here, across those pods that you see coming and going. And what it has is kind of a clever ready or not, right? So this is the readiness probe we talked about earlier, and it basically says, I am not ready until I know that my cache is ready. I've joined the cluster from a in-memory standpoint. Cache is good. Now I'm ready. Send me load. So that concept is actually fairly straightforward. It doesn't take a lot of code here. You can see the ready or not. And if I look at the YAML for that, okay, this is the deployment YAML we saw earlier. You can see there's some Java options where we're constraining the JVM. One thing to watch out for Java, it tries to use all the memory on the host and all the CPUs on the host by default. You have to kind of say, nope, you only have access to this constrained set of resources because I'm running several of you simultaneously. And you can see the ready or not right there, okay? So it's going to make an HTTP request. It's going to hit this guy, and this guy's got some logic right here, and it's either going to return a 200, okay? And the way you basically say you're not healthy is you return something beyond 400. whatever that might be. So the rule is between 200 and 400 is good, beyond 400 is bad. That's kind of the idea, and it'll poll and continue for as long as it can. Now, using that same basic concept, we have a more advanced version of this presentation, a more advanced version of this demonstration, and that is specifically around this thing called the movie store. I think it's still running here. Okay, all right, so let me show you this, because this is more like a real-world application. A fellow on my team named Kamesh built this just in the last couple days, last couple weeks, because we want to show something that was a little bit more advanced than just Hello World. So this is more like a real app, okay? Let me see if I can bring it all up here. And so right now, okay, all right, there's nothing in the shopping cart right now for any of these guys. All right, but let's add some stuff. Let's add some stuff to the shopping cart. So this is more like a typical real-world app. So they have now 3 Beauty and the Beast there. Notice also that is the host name that this guy is tied to, okay? Because there's still a real computer back there, if you will. It's just highly virtualized. It's talking to that guy. If I come over here and actually update this one, okay, go to the cart. You can see here that one. And you notice those are the same servers right there, the 8RFC9. And let's try this one. All right, and add, and then, oh, I made it, got to scale it properly. All right, and those are actually all tied to the exact same pod. Let's go over here and look at it. Movies, let me see how many pods I actually have running. And I have 2 pods running, and the name, there's the 8RFC. Whoop, it disappeared. Come on. This system has gotten slow. Okay, this is what happens when we run too many things. But here we go, all right? So there's the 2 pods that are in question, so my Java code is running on both those. And again, the idea is here it returns its URL to indicate what's happening there. The code for this is actually relatively straightforward, though it is a full Spring-based application based on Spring Boot with Timeleaf as the templating engine, and it's using Spring sessions. So these are just regular Spring sessions that we're interacting with here. Okay, and Infinispan though is making sure that Spring session lives beyond a rolling update. So if I come over here and go into this piece of code, okay, and let's just change this to Burr here. And where do I have this guy running? Okay, I see project movies. Switch to the right namespace, and let's do a canary deployment. Okay, in this case, we actually have 2 profiles set up. You will see specifically the deployment YAML we need specifically for the original one, and then one for the canary. And they're only slightly different. The primary thing is that on the canary side, we actually deploy with 0 replicas, and on the main one, we deployed with 2 replicas. So that means we have a 2 and 0 out of the gate. And if all goes well, let's look over here at our user interface. Okay, and if we got those guys deployed, Tail, and these guys are popular movie store. All right, let's see what those looks like. Okay, so they're up there. They're not producing much in the way of logs, but let's go ahead and run that guy. See if it'll come up for me. And actually, we'll go ahead and take it up to 2. So in this case, it actually takes a little bit longer to start these guys, because this is doing a real workload. It's not Hello World, right? It's doing everything you saw on that user interface, in addition to maintaining all the state across those shopping carts. And so as you add things to the cart, those things stick around. So like if I come back over here and add something else, okay, add that to the cart, whoop, and by default, all right, so there's the 2 things in the cart there. So again, you can kind of see this is actually a little bit slow in the startup, and there's a reason for that. We want to ensure that all the state's being replicated. There's one coming online. And so we specifically, in our deployment descriptor, have an initial delay for the health checks at 30 seconds. That gives plenty of time for things to warm up. So by default, you have an initial delay, you have a timeout, and you have a period. How often do you want to check? That's all part of Kubernetes from a checking standpoint. And we're simply manipulating those to make sure that we can get everything in the game. Okay, so let's see. I just killed one of these guys. Let's see if our shopping carts are okay over here. Where'd they all go? All right. And they look okay so far. But here's where it gets interesting. Let's see here. Okay, so we're still good from that perspective. Let's go ahead and finish killing it. All right, take it all the way down. All right, so if I did an okay job there of all this, yep. All right, there's the Burr movies. So again, we've now rolled out the code change, but the state of the shopping cart is the same. So if I go over here, let's try that one. All right, Burr movies. Again, the 2 items in the shopping cart are still there. And if I go over here, so this is the last one with the old, the old data. There's Burr movies, and you can kind of see there's the original state. So that concept of the canary rollout and being able to incrementally roll things out, I believe, is a very cool feature of all this environment. And we are basically out of time, so hopefully you guys got a chance to see that. All this code is out there in GitHub. I want you guys to try it. Stop making noise. And a couple things to wrap up with. All right, I didn't have time to talk about sidecars, but because the pod can contain 2 containers, one thing you're going to see us working on is specifically this concept here, right here. By default, you got all this code that kind of goes into your business logic for doing things like historics, tracing, and things of that nature. With the case of the sidecar, that all gets sucked out into a separate set of logic. Envoy is the one we're particularly interested in because it's C++ based. If you're running a Node.js application, you don't necessarily want to run a whole JVM as a sidecar. Then it's actually a way big sidecar. But do check out Minishift, Minikube, the Fabricate Maven plugin. You don't have to worry about Eureka and Ribbon in this architecture. That you get that for free. If you want all the instructions for how to do blue-green deployment, canary deployments, things like that, and microservices, we have a whole instruction set out there for you. Check out those readiness probes, and this last GitHub repo is the specific demos I was just showing you. All right, and my time is up, but I'll happily take questions out in the hallway. It looks like I've managed to fill up the whole 50 minutes or so. All right, thank you so much.